Yes, so this presentation also, anyone could reference it anytime. Hopefully, if this gets recorded. Just give me a second. I'm looking for my tab. Okay, all right. Can you see my screen?
Yes, I can see your screen.
All right, perfect. So, hi everyone. Welcome once again to this workshop, I would say, where we get to talk about building interchain native decentralized application with Axelar. And the focus here is not specifically on the Axelar technology, right? You need to understand that while the Axelar technology plays a major role in facilitating those interoperability between chains, it's also important to know that if you have like experience working with or building with Solidity or any of this technology and the blockchain, it's also very important to know that those skill sets are still very, very relevant and very useful. But all that is required is just for you to understand how to interact or utilize the Axelar SDKs, the smart contracts already provided for you as a developer to connect those blockchains together. All right, so a bit background about me. My name is Idris Olubisi. I work as developer advocate at Axelar, and you can find me online everywhere as Olanesoft. Yeah, so let's get started. So I just want to take like a step back to how the whole blockchain thing started, where in 2009, Bitcoin was introduced and by an anonymous group up to this moment called Satoshi Nakamoto. So Bitcoin is the first ever decentralized, cryptocurrency and blockchain network, and it has gained traction over the years. Between 2009 to 2017, we've seen a lot of like quite a couple of chains, right, where we have the Bitcoin, the Ethereum itself, the this popular Uniswap, and some other protocols within the Web3 ecosystem. So the concept of blockchain technology started gaining these recognitions when Ethereum went live in 2015, and people started building because Ethereum introduces the concept of you building smart contracts and also enabling the development of decentralized application on the blockchain, right? So the concept of private permission, blockchain, all of these things within the enterprise settings also started gaining more traction, and everyone started, checking out the potential or exploring the potential of blockchain for supply chain management, healthcare, voting system, and many other use cases, right? So moving on, we have the era of 2017 to 2020, where we start to see more chains go live, new platform being built, right? Where we start to see regulatory development, where government and regulatory body worldwide like creating a framework to govern cryptocurrency and all of those things. We also see the enterprise adoption as shown on the screen, where we have Avalanche protocol, we have the like of Solana, we have Celo, we have Polygon, which is a layer 2 solution scaling Ethereum because there are issues around scalability. So in fact, research and development efforts during this era is focused on improving blockchain scalability, interoperability, and also privacy, which is why you see some layer 2 solutions within this era. They try to see how to scale Ethereum, how to make it easy, how to increase the transaction throughput, and all of those things. So we've also seen like criticism, right, within the space because the old Web3 ecosystem have gone through the phase of hackers, where we've seen a lot of money being moved out of the space due to one leak or the other, or one form of hacking or scam. So there are several regulatory enforcements and action against all of these fraudulent projects, right? And also the need for increase in security and consumer protection were required. And also at this point within this era where we have all of these projects, so interoperability and cross-chain communication is something that everyone starts to talk about. To see now we have a lot of protocols, we have a lot of projects, we have a lot of ecosystem, like different ecosystems, from the EVM based ecosystem to the Cosmos to Polkadot and the Near ecosystem. So how do we connect them together? So the talk about connecting interoperability started within this era. And to add to this, what happened within this 2017 to 2020, we had a lot of decentralized finance application boom, a lot of platform build assets, build a platform where you could trade, you could lend, and also borrow some sort of assets in a decentralized manner. Then things moved on to the era of 2021 to the future, like 2020 now till now, right? And also it's also open to accommodate a lot more protocols. We see the likes of Mirror, where they keep building. We see Uniswap, we see Aave, Uniswap big protocol. They have a lot of products to ensure they become really, really strong when it comes to decentralized exchanges and some other things they offer. We have Somalia for facilitating cross-chain between protocols, right? So, but the question here is that how do we scale when we get to add more and more protocols with capabilities and some other features, right? How do we make this process seamless for new developers or people that are already within the space to quickly, understand the whole cross-chain thing and then start building things? So because we understand that users have different needs. Some users could prefer, oh yeah, I want my application, my privacy level, the privacy level of my decentralized application to be as secure as possible. Oh, users may have another need saying, okay, cost, I want my application or decentralized application to be cost effective, and also security. All of those things you can't really tell, like, this is what your user needs, right? But you can at least talk about some of the things they have highlighted so far, or maybe feedback gotten from users within the Web3 space. So because every decentralized application with different use cases means that more and more decentralized applications are being built, which require like different chains. So we keep having different chains every time, because people are building, people are innovating, the whole ecosystem is growing. But the truth here is that they are growing, but how do they communicate together in the first place? That's where Axelar comes in, right? Axelar, as it stands right now, securely connects all of this blockchain together. So now we've seen the likes of having Bridge and Bridge getting hacked, right? We've seen a popular hack of about 500 million USD and the likes, where it turns out that the bridge that facilitates communication between chains is being managed by a multi-signature wallet. And at the end of the day, that particular wallet gets hacked. Maybe multi-signature wallet requires about, depending on the plan, but ideally the cases we've seen is that it requires about 4 people on the wallet. But if you could access 2 addresses or pretend to be those addresses, either you get hacked or you get their information revealed one way or the other, you can facilitate transaction. That's why we've seen the hack. But Axelar is taking a different approach to it, because they provide a universal interoperability network that securely connects those blockchains together. So because in today's world, we've witnessed, like I mentioned, a shift in instead of having like multiple blockchains being utilized by developers, because you, developer A, wants to build, he decides to build on EVM ecosystem. Developer B wants to build, decides to build on the Cosmos ecosystem. Everyone is building based on their use cases and also their target market. But as a result, there is a growing demand for interoperability, leading to like various market shifts solution, ranging from trustless, like a trusted multi-signature setup, to a trusted custodians, right? However, the increased number of attacks on such system highlights the need of a universal and a secure decentralized protocol, which is the exact problem Axelar is solving. So instead of having a bridge, why not have a protocol itself that also facilitate those kind of transaction and requires validators, which means at this point, Axelar have over 70 plus validators, and which means that any message or transaction sent into the protocol gets validated by some set of validators, right? So, and also this is to ensure the integrity of the network, to improve the whole Axelar ecosystem itself. So, all of these things that I mentioned, Axelar allows you to do that. They provide APIs for you to do it. So in the next slide, I'll be talking about how the Axelar tech stack itself, and as a developer that wants to build, because this presentation is mostly for those that want to build leveraging the Axelar network, right? So developers that want to build, how do you need to think about Axelar, and also understanding the tech stack behind Axelar. So what I'm showing you right now on my screen shows the three layers that we have, which is the application layer, the layer one gateways, and also the Axelar network, right? So the application layer is where we have like the different ecosystem, the Ethereum ecosystem, which are all EVM compatible ecosystem, and also the Avalanche ecosystem, the Cosmos, and the Polkadot. These are like different ecosystem on their own. They have their own consensus mechanism, they have their own approach of building, they have their own way of validating transaction or interaction within their network. So, but that application layer is a representation of how a DApp, as a user, I want to build, or sorry, as a user, I want to use a decentralized application, and as a developer, I want to build. So it falls in that category. Um, so Axelar itself is a proof of stake blockchain network on its own, like you have seen in the diagram underneath that shows the Axelar network, right? So, and this is built on the Cosmos SDK framework, but it is structured in such a way that it facilitates transactions or activities or general message passing within any of this network. Because it's built on the Cosmos ecosystem, it also facilitates transaction between the Ethereum ecosystem to the Avalanche ecosystem or to Polkadot ecosystem. So we have, it has its own set of validators, and these validators, they play a crucial role in securing and handling the cross-chain messages by collectively voting and validating all of those transactions, right? So the application layer, the layer one gateway, you might be wondering what the gateway is all about, and also the Axelar API that we have here in this diagram, like why do we have Axelar API there? So to facilitate cross-chain communication or general message passing requests within the network. For example, you want to send message from chain A to chain B. So chain A, in this case, maybe you want to send message from Polygon to Avalanche. How do you do that as a developer? Now you want to provide an interface for users to enter a message and then move from one protocol to the other protocol. Axelar offers the API for you as a DApp builder, right, to incorporate the cross-chain capabilities into your application as a developer. So this API enables users to send message across the network, right, and also allowing them to interact, not just sending message, but also interacting with your smart contract on the destination chain. So the destination chain in this case means, for example, I want to send something from Polygon to Avalanche, like I mentioned earlier. Polygon is my source chain where I'm sending from, and then Avalanche is my destination chain. Because I'm able to send message from Ethereum, oh sorry, Polygon to Avalanche, it means that I can also interact with that same contract on the Avalanche network, right? All of these things being facilitated by the Axelar gateway that you're seeing here. So the gateway itself, for example, when a decentralized application users initiates like a cross-chain message, it first interacts with the gateway. So interacting with the gateway, this is done like under the hood. You don't need to see anything on the front end. All you just need to do is to have like a click button for them to send message, and every other thing happens under the hood, right? So if you notice on this diagram, we have the Ethereum network. immediately. So you don't need to token superpowers that we have to receive message functionality, right? That which is a function on the gateway itself. So this is already deployed on the gateway. All you need to do is to send in information of what you want to do and then send token. You might be wondering, since we have get deposit address, then why do we need this function for send token? Remember I mentioned deposit address generate an address for you, which means that somebody else still needs to now send money to that address, and then before it now gets routed to the destination chain. But this send token is a method you can call on your own contract itself. Pass the destination chain name, the address, the asset that you want to send, and the amount. And with this request, by default, when any user interacts with your smart contract or you want to test out your smart contract, you can easily send token from anywhere to this destination chain on your chain, right? To this destination chain, and then deciding on any assets that you want to send. We have various assets. All of these things can be found on our documentation, where you can see assets that we currently support that you can send from one contract to the other. Then the last one on the whole token transfer or token superpowers is the interchain tokens, right? So interchain tokens allow you to send tokens across chains, right? And also build your own assets. So you can decide to build your own platform to bridge assets from one protocol to the other. What interchain token does for you is that you just take your token from the source chain and then help you move them to the destination chain. So how is this different from the send token that I mentioned earlier? So this allows you to do a lot of things aside from just sending token. So you can do like asset bridge, you can build your own asset transfer on and all of these things will be regarded as a native interchain decentralized application. So now that's it for the send token part. I've mentioned send token a lot, send token from one contract to the other. So now let's talk about the send messages, which is also another superpower, which is one of the fastest thing to do with Axelar. And it's called contract, right? What contract is doing for you is, I mentioned earlier on that if you want to, Axelar allows you to send message from one blockchain to the other. So this is what we're actually utilizing to send message from one blockchain to the other. So for example, I want to send from Polygon to Avalanche, right? What I'm going to do is to deploy this particular contract with this core contract function. Sorry about that. With this core contract function, then when I deploy it, what happens is that I can easily pass the destination chain when I want to test the contract address and the payload. This payload could contain anything you could think of, JSON, string, anything. As you can see, the identifier is byte. So you could literally take a JSON, a string, or any data type that you want to save into this payload. Then on that same contract, we have the execute. This execute here, you can see it's denoted by underscore. This is what gets executed on the destination chain. So if I want to send hello world from the source chain Polygon to Avalanche, because I've deployed this contract, the system, the Axelar network already understand that whenever this action is initiated, this execute action gets run on the destination chain. So this is like sending, and then the other part called execute is receiving. So when I mean this is sending, is the core contract function is for sending, and then this execute automatically executes this action on your behalf on the destination chain. You just need to deploy once and then test, right? So this also takes in source chain to understand where the message is coming from, the source address, and then the payload. Within the payload, it takes in the payload that was sent earlier on and then decode whatsoever it's in that payload, and then do the next line of action to how to register that particular message on that chain, right? So this is just for sending messages across. So let's move on to the other one, which is core contract with token. So we are no longer sending messages alone, right? We want to send messages and also probably a token. For example, a token here in this case, I mean an asset, right? So while we are sending hello world, we still also want to send a specific amount to that chain. So the same process happens for both core contracts and also core contracts with token. But the only difference here is that you can see the additional parameters that we have here, which is the symbol of the token and the amount of the token, right? And then once that is sent, the underscore execute with token also get executed on the destination chain, takes in the source address, the source chain, and then gets the payload, get what is inside, get the token, and gets the amount. So this is like an overview, which I would show in, like, I think the next slide, of how it's actually being implemented shortly. Yeah, so to the demo part. But before we proceed, just to wrap up on the interchain side of things. So now it says executed, that's completely done. So I now have access to that same Oscar First test token on Binance, on Avalanche, and on Kava Network. So let's see it. So if you click on done, it just automatically, let me just zoom out a little bit. All right. So if, as you can see on the screen, you can see the token shows registered here, right? And then we have here deployed. We have also deployed here and deployed here. Let me just zoom out one more time. Okay, this is strange. I'm not sure why it's not zooming out. All right. Okay, yeah. So now we've successfully deployed the same token we registered on Polygon, on Binance, and Avalanche, and then Kava with just one click. So, but still, because we're able to deploy, doesn't mean that we cannot interact with those, with the token. So let me just send a particular, say my balance is showing 10, which is the 10 minted token that we did earlier on. And but on all other protocol that we deployed to, is showing 0, 0, and 0, right? Which means that on Binance chain we have 0. So, but we can also still send them. So see what I'm about to do, send interchain token, which is part of what I explained earlier on, that function that facilitates sending token between protocols, right? So I want to send to Binance and I want to send 3 tokens, right? I can just click send. What happens behind the scene is that it takes my approval to send because I am the owner of the token. I deploy the contract. Then after approving, I'm currently accepting a MetaMask confirmation right now. So now I've accepted the MetaMask confirmation. It's about to send 3 tokens out of the deployed or registered total amount of token on Polygon to. You can also check the progress sending. So when you click on the progress, you see it on the testnet Axelar scan to see the status of the transaction. And it takes, let me see. Okay. It says sending in progress. So this is currently loading and you can see like core contract has been made already. Gas has been paid, confirmed. It's trying to confirm. This is because we have like set of validators, trying to confirm the transaction on the network before it gets approved. Then once it's approved, that token will be sent from Polygon to Avalanche. This is a UI that you could interact with, but probably not useful for developers. But sincerely, for you to see how things work with UI, you can be able to interact on this platform for free and then sending assets around. So that's it for the interchain part of things. Now let's switch to the demo where you actually see the coding, like the contract itself that does all of this interaction. So this is still showing sending, but as you can see here, the balance is already 7. So it's still in progress. Once it's confirmed on the network, we should have the balance here appear as 3.0, right? Which is the total amount of token that was sent. So now to the demo part of things, let me quickly switch to my Okay. All right. So let me share my screen right now. So all of these things that I'm talking about, like the examples that I'll be showing. So I want to believe right now you guys can see my. Okay, let me just zoom in. Okay, I'm not even going to talk about this. So there's a project we call Axelar example. You can find it on the Axelar network. All you need to do is to clone this particular project. So let me run. Let me show this. We don't need this. So, and the good part is that this project contains like README for you to start building quickly. So you don't need to, even if you find the documentation, maybe you don't understand and you want to get the whole thing up and running and get started quickly, so interact with Axelar. You can utilize this Axelar examples. It contains like code snippets for you to use. In fact, you can use any of those code snippets. That's why we created it in the first place for EVMs. All of these things I mentioned to send token, core contracts, web, and all of those things, right? So now this is like one-time setup that you need to do. When you clone the repository, I've already done that, so that I don't take much of your time. All you just need to do is to do npm install and then npm compile to compile your smart contract, right? So let me npm run build. Let me just do that. npm run build. So right now I can run the build, and what's currently happening is that all the contracts I have is currently being compiled. And if you're running for the first time, what you need to do is if you're running for the first time, what you need to do after running and everything gets compiled successfully, you need to do this next step, which is also a command that helps you to copy instead of manually doing like environment keys and all of those things. Because right now I want to utilize local environments for my blockchain, right? So you can just run this command, and what it does is that instead of doing it manually by copying things from example.env, system just copy whatever is in example.env file to a newly created env file for you, right? And now we have this. So I've already compiled this, right? One good thing about these examples is that you can test locally or test on the test net. Like you can literally change environments, right? But what we do is that in this demo, I will try to check my balance. So this is something you can do on your own locally to see the balance. One good part is that the token that gets deployed locally, you can see the balance by just entering this command line. So you can see I typed npm run check balance, right? And then I'm specifying the environment here, which is local, right? And then I click on enter. So what it's about to do for me is to print out all the balances for me, right? So let me see which error am I getting. Could not detect network. Okay, yeah. So you are likely going to face the same error, but what you need to do here to fix this is to run npm run start. Because do you know why? We are trying to check a balance of what is on the network without starting the network. So that's not possible. We need to start the network locally before we'll be able to check the balance. So I can just do npm run start. So if you notice what I'm doing, I created a new terminal for me to do this, right? So you need to do that also. If not, you run into several errors, right? So now I've used the command to run the local chain, like running all the local chain on my own PC, right? And I can see that they get deployed. I have about I have the Moonbeam network, I have Avalanche network, I have Phantom, I have Polygon, and I have Ethereum. So all of this network basically is something that is running on my local host as it is right now. So, oh, did I stop share? Sorry. So all of these things is what I have running on my local host, right? So I have them running. I wanted to click hide, sorry. So I have them running right now, so I can proceed to now print balance, right? To check the balance of what is available for me locally. This is exactly how it looks like on the testnet or the mainnet. But what I'm just doing is I'm running it locally. So I can just say npm run check balance right now, and then specify the network so that you already understand that where the balances I want to check is the one from running on my local blockchain. So as you can see we have different native tokens, like I mentioned. We have the Moonbeam network, Avalanche, we have Phantom, we have Ethereum, we have Polygon. All of these blockchain, they have their own native token already at 100, right, for you to validate or utilize for any transaction. And then we have AUSDC too, right? So AUSDC in this case also is also an asset that is useful for you to deploy or send around, right? So this is it, right, for you to get started quickly. And before I kind of wrap up, I want to show what we have there. So there's two important folders that you can check out, which is the examples. Then under examples, you see EVM. I'm not sure if I need to zoom in, but hopefully, I still forget this command for zooming in. All right. This EVM folder contains literally everything you need to get started with, right? The core contract that I mentioned, we have one thing is that we even have the deploy script. If you want to utilize the deploy script, you can utilize the deploy script to see how to test them. If you want to, this is the smart contract code I was talking about that you can just copy and paste, understand what is going on, and then utilize them within your own application. We have core contracts with token. Like I mentioned earlier, the core contract just send messages from one blockchain to the other, but core contracts with token sends messages alongside a token that's an asset. We have the core contract with token express. This is also something similar with core contract token, but it's pretty much faster. This is depending on your use case, right, that you want to achieve within the decentralized application that you are building. We have the cross-chain lending. We have tons of demo here. In fact, we have the NFT linker. So I've been mentioning token, and you might have noticed I just said ERC20 token, right? But you can also utilize it for ERC721 for NFT. So if you want to move NFT from one place to another. So this is what we have, literally no UIs here. But under the Axelar examples web, this is a React application that I'm not sure time permits, but it's a React application that you can literally just follow the command line here. It also contains like a README for you to start. Then once you start the project, once you start up this React application, you'll be able to send token, you'll be able to send message, you'll be able to send NFTs, you have a UI that you can test directly. All of these things happening locally on your blockchain. So expect it to be pretty much fast. You don't need extra confirmation. Everything just happens on a click because everything is running on your local blockchain, right? Considering that you are using the local environment. But if you want to use the testnet with these examples, these Axelar examples, you can also run the same command, but remember that you need to specify which environment you want to run it on. So for example, when I want to run node script run check balance, I specify local, right? So local environment indicates that I want to run this particular action locally after deploying my script. So if you do not specify local, right, you specify testnet, what Axelar would do for you is to reroute all of these things to testnet. So we have like two blockchains that you can test with. But we like to always save faucets because it's very hard to get these days for you to test. So I'll always recommend you test locally because this is something that would also happen on the testnet. So why not do it locally? Because it's faster, it's cheaper, you don't have to pay for any token or start looking for faucet up and down to send and all of those things, right? So let me just switch back to the presentation And one good thing is that I'll also like be always available for any question. I think we have a dedicated channel on the Oscar Discord for any questions that you might have. Give me a second. I'm trying to look for the window. All right, cool. So that's like everything. The key takeaway here is for you to understand that there's this project called Axelar Examples where you can check out the smart contract to utilize when you are building your decentralized application, and also to show you what we have for you out of the box, leveraging the Axelar network itself. So what next here? What next here is it's very easy to build interchain native dApps, right? Leveraging Axelar. But if you have, if you have questions or you need additional support, we also have dedicated channels for developers, right, on the Axelar Discord. So you can just join the Axelar Discord and then ask any question. It's a forum, so you can ask questions, ask anything if you have errors, bugs. I'll also be available on the Oscar Discord for any questions, complaint, or you need snippets, or you're trying to navigate through the docs, you don't know where to find something, or you want to receive the Axelar faucet, you are looking for ways to do that. Yeah, any question basically, I'll be happy to help. And yeah, thank you very much. So if I always like, if you want to give a feedback about the presentation, you can just feel free to scan this QR code and give feedback on what you were able to learn within this presentation and how it has been able to help you understand Axelar better. Thank you very much, Ken.
All right, thank you so much, Idris, for that very well detailed presentation and workshop. I believe most of us have been able to know more about Axela and how they could utilize it to build innovative projects for the hackathon. So